Hey, in this video, we are going to talk about hypothesis testing for the mean with the population standard deviation unknown. And yes, the last video was super long. However, this one will be a lot shorter because it's just a very slight difference. Now that you know how to do hypothesis testing for mean, there'll be a slight difference when the population is unknown. So looking at this page, it says a mechanic believes that people travel less than 4,000 miles between oil changes. So we know what he believes, that's our claim, less than 4,000 miles. A random sample of 15 cars getting an oil change has a mean distance of 3,825 since having an oil change, with a standard deviation of 205 miles. Now, this is in sigma unknown, so you're going to follow this method throughout this whole section. But then when you get to the quiz, the difference between sigma unknown and sigma known, here it says a random sample, blah, 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 blah. So that means this is the sample mean, and that means this is the sample standard deviation. Going back just really quick, here we had, there's a good example here. Population standard deviation is listed. It says it's a sample mean, and then a new sentence happens that it says population standard deviation. Whereas this problem that we are currently on, it says in the whole sentence that we're talking about a sample, the sample has a mean and the sample has a standard deviation. So we're talking about S, which means sigma is unknown. Assume the population is normally distributed, and we have alpha equals 0.10 level of significance. Okay, so we're just, we're doing, next up the camera. We're doing this one where I give you the p-value just like last time, just to kind of get the hang of it. So this, well, let's just start with our hypotheses. So we have our null, and we have our alternative. And again, we are still in mean. Next video will be proportion. So we are in mean. And this one says less than 4,000. Oh, here. Less than 4,000. And the top one, the alternative is always the inequality. The top one is equal to. Remember inequality, I said these, but it also means not equal. That is also an inequality. The only equality is equal, and that's for the null. Okay, so we're doing less than. Less than is one tail. No, of course it's one tail. Hang on, there we go. Less than is left tail. I'm going to fill in this over here. This is the level of significance is drawn at 0. or alpha is 0.10, and our p-value is going to be here. This is a number line, and we have 0.003. That is our given p-value. So this is in the reject region. Reject the null. So, conclusion. Well, we're going to reject the null. And then we are going to say, because we're rejecting the null, there is sufficient evidence to support the claim that, and then we go back up to the top, people travel less than 4,000 miles between oil changes. All right, so that was a problem without using the calculator. He was already given, so just literally nothing changed. Right, because we didn't use the calculator. Now that we're going to use the calculator, now something's going to change. Okay, so here we have another problem. Now it says draw and label your p-value, which means it's not given in the problem. And so it says the manager was considering changing his sales tactics and wanted to appeal to younger CEOs by having a younger team. He randomly surveyed his team and determined the average age of employees on his team currently. He found the sample mean was 47.8, the sample standard deviation was 10.3, and he wanted to know if, and so here's our claim, the mean age is higher than 45. Assume that all employees are normally distributed and the significance level or alpha is 0.05. And then here's the claim one more time here at the end. The mean age greater than 45. Okay, so our hypotheses, back to our null and alternative. We are talking about the mean age being higher than 45. So let's get our muse in there. Might be too close together. I might have. Oh, no, I can do it. Muse. And higher than is greater than 45. And then null is always equal to 45. Draw pictures. So let's just, before we get to the calculator, this is greater than. Greater than is a right tail test. And we know that that is at alpha, which is 0.05. I like to put everything I know without the calculator first, so I have everything in the right spot. And then all I need to do is look on my calculator for P and determine which side it goes on. Okay, so back to the beginning, because this is where the calculator always resets to. So we have inference. We are on tests in chapter 9. We are still on one mean, but this time, because we don't know sigma, we are going to use the z-test. Did I say that right? I feel like every time I just question myself. Just a second, this is how we check. Right here. It says population standard deviation. So nope, I said the wrong one. It's actually the t-test. And I know because here's asking for sigma and I don't have sigma. Right, yes. Okay, so we're going back up to the t-test. See, it's a good check. Just check it every time you start a new problem to see, especially on the quiz, to make sure you're using the right test. Okay, so here mu is greater than 45. So the null is 45 and the alternative is greater than 45. Input statistics, so X bar, oh, that's random. It just happened to do 40. A very close number to the answer, 47.8 is what we wanted. S, which is what we have, is 10.3, and N, how many did he ask? What is our sample size? He randomly surveyed his team to determine the average age of people on his team. Wow, this problem didn't include it. That would have been helpful to know. Okay, so let me just add the team. I'm just doing this so we have a problem to do, but they will be given. It'll be given to you on the test. Unless I'm missing it. Found sample. He randomly surveyed his team. Okay, it doesn't say. Okay, so we're going to say that on his team there are 15 people. Okay, why? Because I said so. There's nowhere to justify that because it's not written in this problem. I am just adding that in as the teacher because we need it to solve the problem. Okay, so it's 15. And then we have 0.05, so we are done. And we get that our p-value is 0.15. Our p-value is larger than our alpha. There's our p-value. And so let me just write it on the picture so we know what it is. It is 0.1551. P is larger than alpha. So we are going to reject. Let's double check on the picture. And so we can see, I'm going to zoom in just a little. Here is our p-value. No, that's our alpha. Oh, p is smaller than alpha. What did I do? P-value. Oh, because we're on T. Okay, this is not a number line. That is what I did wrong. Okay, so here is where our p-value falls. So I would double check with the calculator because we can't just do it like a number line. Okay, here is where our p-value falls. So here is our alpha, and here is our p-value 0.1551. Yes, okay. And so we can see that we are going to not reject. Do not reject the null. Okay, so the conclusion is, there's our conclusion, and then our interpretation is there is not sufficient evidence to support the claim that the mean age of his employees is significantly higher than 45. So a few things here as we wrap up this question. One, this is what I did wrong. This number line right here is T, it's not P. So when I was trying to place P on this number line in terms of greater than or less than, that messed me up. So always go to the picture to see where your P falls, because you could look at T right there, but then alpha, it's just a different scale. So I didn't really emphasize this hard enough in the last video, probably because I was talking about everything else in the last video. So as a reminder, we are just looking at this picture. We see that the T, or our p-value, our orange, is in this part. It's not completely in the shaded part. It's in the shaded and the white. So since it's over here, we do not reject. It's in the do not reject region per this last page right here. It's in this, where we were right-tailed, it was in this do not reject region. Okay, just one more because you're getting the hang of it. And I just wanted to do one where we enter the statistics ourselves. So the owner of a shoe store wants to determine whether the average customer, so we're determining, this is our claim, whether the average customer bought more than $100 worth of shoes. She randomly selected 10 receipts, and here we go. All right. It feels like there's not enough information in this, but remember, there's a table. So this calculator is going to calculate our mean, our standard deviation, our n. It's going to calculate all that for us. So this one is fine. So we have our hypotheses, our null, and our alternative. And then let's throw a mu in there. I'm going to be happy in the next video when it's all p, no more mu. All right, so the null says more than 100, greater than 100, which gives our, not something else, that's our alternative. So our null is equal to 100. Closer to my mu. Okay, this is greater than, so it is right-tailed. And our alpha is not given. This is a good time to point this out. When alpha is not given, I'm just going to write this down. It was given last time, so I forgot to talk about it. When alpha is not given, it is assumed to be 5% or 0.05. And you'll notice on your calculator, it always defaults to 5%. So that's why, because when we don't know what it is, that's what it is. So this is not me making this up like I did in the last one just to get us through. This is a fact that I forgot to tell you in the last video, and it's for all three of these sections. In fact, I probably should have told you in chapter 8. You know what? I might have, because I recorded those videos like a week and a half ago. Okay, so let us get our p-value, and we're just going to go back far enough because we want to be. Oh no, we have to go all the way back here. This is what I did wrong earlier. I was doing it by myself. And I was like, okay, I'm just going to go back. Oh, gosh. What did I do? I said, oh, I'm just going to go back to this screen. And I used the wrong mu because I forgot to go back far enough. So you have to go back far enough to go to the very beginning to have the mu. Okay, so this is supposed to be 100. And this is greater than. Perfect. Now, here's where I use a data set. And I'm going to type in, oh, this is what I was talking about. See how alpha defaults to 0.05? It'll always default to that, and you only need to change it on when it specifies that it's different. Okay, so we have 89. There's only, I made a smaller table in this video because the last video was too long in many ways, but a table as well. So I'm entering my table in. Remember, keep everything in the V1 value column. Don't put anything in the frequency column. Let me just double check because I was talking 65, 119, 109, 119, 89, okay, perfect. Alpha is great. And now see that it gives us the X bar, the S, and the N right here. So we didn't need to have that in the problem. It all comes from the data set. So there's our p-value. Oh, I forgot to put myself on the picture. And I calculated that the p-value was 0.1894. A lot of the questions ask for it separate. So I want to make sure we're writing it separate. But we'll also see we have it picture right here. So our p-value is going to end up, give me something fun. Okay, actually not fun. So our p-value is going to end up right there. 0.194. And then there is our cutoff, our alpha. So we can see that our p-value falls over here. It falls, here's the cutoff that falls over here. So it is in the do not reject region. Something I wanted to say. I don't know if you noticed this, but when we're writing this, do not reject the null with the word not. The word not is also in here. There is not sufficient evidence. So I don't know if you caught that earlier. I don't know if I said that in the last video, but that's kind of one way to remember how to write the conclusion and interpretation. The nots go together, and then we do one that is. There's no not in here, and it says it. Okay. There is not sufficient evidence that my font changed colors. There we go. What are we talking about? We are talking about the average customer bought more than $100 worth of food. There is not sufficient evidence that the average customer bought more than $100 worth of shoes. Okay, short and sweet. Again, just like in chapter 8, once you know how to do this, it's just a matter of when you choose T and when you choose Z. But other than that, the steps are the same. Again, to repeat, population standard deviation is not given. It is not known. It is what it is. So that is why we are using T instead of Z. All right, I am not going to cut off my video at the wrong spot this time because I cut it off mid-sentence last time. If you have any questions, send me an email. Otherwise, I will see you in the next video. Bye.